Estimations. What is estimating about? Well, it's about guessing amounts. Sometimes it might be like the picture, guessing how many things there are in a jar. But basically it's to give us an idea about what's happening in a particular situation. If it's a measurement, what's the number closest to? So for this measurement here, is it closer to 0 or closer to 10? Well, we'd say it's pretty close to 0. Although it would be more accurate to have the particular number sectioned off throughout the line so we can get a more accurate, detailed measurement. When estimating, we're rounding off our numbers to a particular value. We use symbols. That we can use either one of these two symbols to refer to the meaning approximately. So when we cut off numbers, we need to decide what we do to the last digit before we're cutting it off. And this little statement here will help you. If it's 5 or more, we let it soar. That means we go up 1. If it's 4 or less, we let it rest. That means it just stays as it is. So an example of that is our number here, 328.045. If I was rounding this to the nearest 100, I'm cutting off the digits after the 3. Now the first digit that I'm cutting off is a 2, so that is in the 4 or less category, so it just stays, the 3 just stays the same at 3. If I was rounding to the nearest 10, that would mean I'm cutting it off after this 2. The number that I'm cutting off is an 8, which is great 5 or more, so I need to add 1 to the last digit. So now that 2 turns into a 3 and it becomes 330. To the nearest whole number, or sometimes we say to the nearest integer, I'm cutting off all of the numbers after the decimal place, point. So that number there is a 0, so that just stays the same at the 8, so 328. So you can see 328 is really close to 328.045, so this is our approximation. To one decimal place, I'm cutting off one number after the decimal point. So here it would be the 4, so the 0 stays the same. 2 decimal places, I'm cutting off after the 4, so because I'm cutting off the 5, I add 1 onto the 4, and that becomes 0.05. So one way to estimate large numbers is rounding each number to the very first digit. So when you round to the first digit, you should have one digit that's non-zero and all the rest are zeros. So basically 2 is my first digit, so I cut off everything after that, and because it's a 1, my 2 stays the same number, and I fill up all my gaps with zeros. If the second digit is the 5 or more, you need to add 1 on to the first digit. So for this one, 3,827, it becomes 4,000 because what I'm cutting off after the 3 is 5 or more, so we add 1 to the digit 3, turning into a 4. Some examples here. You have a look at 5,295 would become 5,000 because you're cutting off the 2. The 683 would become 700 because the next digit is an 8, 5 or more, so you add 1. For 3,199, even though these end numbers are nice and big, the number that you're cutting off directly after the 3 is a 1, so it stays the same and it goes to 3,000. Sometimes you can use this when you're doing large sums. For example here, working out 905 plus 59, you have to do your algorithm. However, when we round off, we can go, well, that's about, what's my answer should be, around 900 plus the 60, so about 960 would be, your answer should be around there. For this one, the 1,965 rounding to the first digit would be approximately 2,000, minus the 495 would be about 500, so 2,000 minus 500, the answer should be somewhere around 1,500. For a multiplication kind of question like that, we would say for this one, 300 times 50, rounding each one to the first digit and then going 3 5s are 15, and then I've got 1, 2, 3 zeros in my question, so 3 zeros in my answer. For the next one, it would be 400 divided by 20, so you just if I can cancel down the zeros, and I just work out 40 divided by 2 is 20. Thank you.